let's start with the last this thing, numerical related to your BGAM method. So the question that we have is maximize z is equal to twice of x1 plus thrice of x2 plus 4x3. The numerical is simple, just a small there is modification here. So subject to 3x1 plus x2 plus 4x3 less than or equal to 600. Then we have another constant which is twice of x1 plus 4x2 plus twice of x3 greater than or equal to 480. And then we have twice x1 plus thrice of x2 plus thrice of x3 is equal to 540. We have one more constant, that is x1 comma x2 comma x3 are greater than or equal to 0. So this is the question that they have given. Now here you can see this is the mix of different inequalities, right? So it would have here we have less than or equal to, we have greater than or equal to, and we have only equal to, right? So now while considering the artificial variables, how we are going to consider them for that particular sort, I've taken this numerical, and now after seeing to the given LP, it is very evident that it is in the standard format, right? We do not have a negative sign in the RHS, right? So it is in the standard format. The equations are also the linear equations that we have. So we can move ahead, and instead of framing out to be into the standard format, as it is already in standard format, we can proceed and directly start with the framing of the simplex problem, right? So framing simplex problem is important step here, right? So here we have the objective function as maximize z is equal to twice x1 plus thrice x2 plus 4x3 subject to. Now we have to remove the inequalities, right? So for removing the inequalities, we'll have to remove the inequalities with the help of the slack variables and the artificial variables, right? So it is thrice of x1 plus x2 plus 4x3. Now here the inequality here is less than or equal to, and for less than or equal to, we only add the slack variable, right? So plus s1 is equal to 600, right? Now the next constant we have is twice of x1 plus 4x2 plus twice of x3. Now we have greater than or equal to inequality. So for that purpose, we are going to consider both the slack as well as the artificial variable, but the slack variable is to be subtracted and the artificial variable is to be added. So it will be minus s2 plus a1 is equal to 480, right? So this is the our second constant. Our third constant is twice of x1 plus thrice of x2 plus thrice of x3. Now what we have to do in case of equal to sign, right? Now for equal to sign, we are not going to consider the slack variable. We are only going to consider the artificial variable, right? So here we are only going to consider the artificial variable. So remember this, for that particular purpose only the numerical is taken. So when it is greater than, here we can write x1 comma x2 x3 s1 s2 a1 a2 greater than or equal to 0, right? So here somewhere you can write for greater than or equal to inequality, right? So for greater than or equal to inequality, you have slack variables and artificial variable, right? But slack variable will be what? It will be a negative slack variable for greater than or equal to. For less than or equal to, there will be a positive slack variable, right? And if there is only is equal to sign, so only is equal to sign is there, so there will be a artificial variable, that also it will be having the plus sign only, right? So here it is very, very important. You should make your own notes or important points like that, like this, so that you yourself will remember this, right? So I hope you have understood this. Now we can move ahead and we can frame out the initial simplex table. So initial basic simplex table can be prepared, right? So we have CB, we have CJ, we have basic variable. 1, 2, 3, 4, 5, 6, and 7 are the variables as of now. 1, 2, 3, 4, 5, 6, and 7, and 1 for solution. Right, the variables we have are x1, x2, x3, s1, s2, a1, and a2. So the coefficient, yeah, we forget to write the objective function properly. So an objective function, it will be what? It will be 0 s1 plus 0 s2, and we have a1 and a2 here. But now this is a maximization problem. So in maximization problem, what will be the case? The there particularly you'll be giving a negative, multiplying the artificial variables will be negative coefficient, that is minus m. So here it will be minus m a1, and here it will be minus m a2, right? So this is our objective function. So here we'll be having the coefficient as 2, 3, 4, 0, 0, minus m, minus m. Why minus m and minus m here both? Because this is a maximization problem. It would have been a minimization problem, so it would have been plus m and plus m as the coefficients for artificial variables. And then we have here is solution. So how many constraints are there? There are three constraints, right? 1, 2, and 3. So there will be three basic variables, right? So as of now, our first constraint is considered. We only have slack variable. So we are going to consider our first basic variable as our slack variable. The next, constant, we have both slack variable and artificial variable. So the priority is to be given for the artificial variable. So we have taken the artificial variable into consideration. And lastly, in our third constant, we have only one artificial variable. So the priority, or there is no need of priority. Here we have only artificial variable, so artificial variable is considered, right? So this is the table that we have as of now. So the coefficients we can write: for S1 it is 0, for A1 it is minus m, and for A2 it is minus m, right? So we can start filling this thing. For considering our first constant, it is 3, 1, 4, 3, 1, 4, 1. Here it is 0, 0, 0, and solution will be having 600. Similarly, for next constant, we have 2, 4, 2, 0, minus 1, 1, 0, and it is 480. And lastly, we have it as 2, 3, 3. We have 0, 0, 0, 1, and here it is 540, right? So I'm hoping that you have understood this. Next step is what? We'll have to find out Zj, and we'll have to find out Cj minus Zj, right? So if we start finding out Zj, sorry, this is a minus sign. I'm no, yeah, I'm going to write it as minus here. So it yeah, it is minus m, right? So so for first values, it is minus 2m, minus 2m, so it will be minus 4m. Next it is minus 4m plus minus 3m, so it will be minus 7m. Similarly, here it will be minus 5m, here it will be 0, here it will be m, here, right? So here it will be minus m, m minus m, here again it will be minus m, and it is 600 m plus 480 m plus 540 m. So all this will have a negative sign, so it will be 1020, m here, right? So if we find out Cj minus Zj values here, so it will be 2 minus 4, no, it will be 2 minus, no, 2 plus 4m, 2 plus 4m here, it is 3 plus 7m, right? 3 plus 7m. Nextly, we have 4 plus 5m. We have 0 minus 0 is 0. 0 minus m is minus m. This minus m plus m is 0. Minus m, and again here it is plus m will be equal to 0, right? So now here we can see, it is a maximization problem. So for maximization problem, all Cj minus Zj values should be less than or equal to 0. But here what is happening, if you see, the first three values are coming out to be positive value, right? So here we can directly write all, no, yeah, it is not visible properly, so I'll be writing somewhere else. So all Cj minus Zj values are not, you know less than or equal to 0, hence iterate further, further. Right? So hence we'll have to iterate further. So for iteration, what we'll have to do firstly is to identify the key column. All right. Now the maximum value amongst the Cj minus Zj values to be considered. So how to find out the maximum value? We can assign any bigger value to m, say 1000. So first, for the first value, we'll be getting the value as 4002. The next value will be 7003, and the third value will be 5004. So our second value is the bigger value, right? So you can take this as the key column, and your x2 will be the entering variable. So for key row identification, we require the ratio values, right? So the first value will be what? 600 divided by 1, it is 600. 480 divided by 4, it will be coming out to be 120. And 540 divided by 3, so if you do, it is coming out to be 180, right? So for key row, the smallest positive value is always considered. So this is our smallest positive value, that is 120, and this is the leaving variable. We can mark this leaving variable, right? Right. Now what we have to do is we have to construct the new values. So uh, you can particularly, I'll be directly moving towards the next iteration, new values. I won't be writing this particular this particular table again, but I'll be requesting all of you that you yourself try to meanwhile when I'm drawing this, you can complete your table as well, right? So so that we can cover this numerical well within the time, and there will be no time pass because of this, right? So let me draw the new table directly, and meanwhile you can also engage yourself in calculating the values and drawing the new table, and then you can compare, right? So because now that you know how to calculate the new values, right? One. Is x1, x2, x3, s1, s2, a1, a2, right? So this 2, 3, 4, 0, 0 minus m, minus m. So the leaving variable was your 120, that is a1 is your leaving variable. So no, I can directly mark a cross for this particular uh, column, right? So the entering variable instead of a1 was your x2, right? Here it is s1, here it is a2. So 0 minus m, and x2 has a coefficient of 3, right? So the new values of all the, the new value of the key row happens to be 2 by 4, that is it is 1 by 2, 4 by 4 is 1, 2 by 2 by 4 is again 1 by 2, then we have 0, we have minus 1 by 4, and then we have it as 0. It is 480 by 4, so it will be equal to 120. Similarly, the new values of S1 in the S1 row and A2 row is to be calculated using the formula. So the new values that come out to be are 5 by 2, 0, 7 by 2, then it is 1, 1 by 4, then it is 0, and it is 480 here, right? Nextly, the new values for the A2 column are 1 by 2, 0, sorry, A2 row is 1 by 2, 0, 3 by 2, 0, 3 by 4, and it is 1 here, and it is 180 here, right? So I can calculate the Zj values and Cj minus Zj values, right? So Zj value will be 3 by 2 minus m by 2, right? So 3 by 2 minus m by 2. Nextly, it will be 3 only, right? Nextly, it will be 3 by 2 minus 3m by 2, 3 by 2 minus 3m by 2, then it will be 0, it will be minus 3 by 4 minus 3m by 4, minus 3 by 4 minus 3m by 4, and lastly it will be minus m. For this particular, so 120 into 3 is 360, 360, and it is minus 180 m, right? So I'm hoping that you have got this values. So for finding Cj minus Zj value, it will be 2 minus 3 by 2 plus m by 2. So it comes out to be 1 by 2 plus m by 2. Here it is 3 minus 3, that is equal to 0. It is 4 minus 3 by 2 plus 3m by 2. So comes out to be 5 by 2 plus 3m by 2. Next it is 0 minus 0, that is 0. It is 0 minus 3 by 4 plus 3m by 4. So it will be 3 by 4 plus 3m by 4. Next it is minus m plus m, it will be equal to 0. Now, we have to it is as it is the maximization problem. So all Cj minus Zj values should be less than or equal to 0. But no, in first instance only, if we see our first value, then our third value and our fifth value are not less than 0, it will be definitely a positive value, right? So if you put 1000 in place of m at every place, so what you'll be getting some values, and amongst this the maximum value comes out for this variable, which is your x3 variable, right? So x3 variable, so this will be your key column, and you'll have to find out key row with the help of the ratio column, right? So here it will be a ratio column. It will be 480 divided by 7 by 2. That will be 480 into 2 divided by 7. It will be 960 by 7. 960 by 7. Here it will be 120 into 120 into 2. So it will be equal to 240. And nextly it will be 180 into 2 divided by 3. That is 360 divided by 3. That is equal to 120, right? So it will be 120 here. So now amongst those all the values, the lesser value is 120, and no, this particularly will be your leaving variable, and this is what, this is your key row, right? So this is your key row, and now this particular statement here, hence iterate further, hence iterate further. Now that we have identified the entering variable and the leaving variable, so what we can do is we can frame out the next table with the new values. So CB, we have 1, 2, 3, 4, 5, 6, 7. This is for solution. So CJ, it is basic variables. Okay, so basic variables are x1, x2, x3, s1, s2, a1, a2. This is minus m, this is minus m, this is 0 and 0. It is 2, 3, 4, 2, 3, 4, and here it is solution. Now that we have identified the entering variable and the leaving variable, so that should get presented properly in this table. So the leaving variable was a2, and instead of a2 we have entry of x3, right? And this x2 and s1 will remain same. So s1 will have the coefficient 0, x2 is 3, and x3 is 4. So let's concentrate upon key row first, that is our last row, that is x3 row. Here the key element is 3 by 2. So every element, for the new value of every element here, old value should be divided by the key element. So that is 1 by 2 divided by 3 by 2 will be equal to 1 by 3. Nextly 0 divided by 3 by 2 will be coming out to be 0. 3 by 2 divided by 3 by 2 will come out to be 1. 0 divided by 3 by 2 will come out to be 0, and 3 by 4 divided by 3 by 2 will be coming out to be 1 by 2. Now this is, a1 and a2 are not the part of our variables, right? So both of this are of no use to us, right? And lastly it will be 180 divided by 3 by 2, so it will be obviously 120 only. Nextly, the S1 and X2 values we have to find out. So for S1, let's start with S1. So S1 value can be written as 5 by 2 minus 7 by 2 into 1 by 2 divided by 3 by 2. So if you do the calculation, the value will be 4 by 3. The next value is, that is 0. So 0, the new value will be 0 minus 7 by 2 into 0 divided by 3 by 2, and the value remains 0 only here. The next value is 7 by 2 minus 7 by 2 uh, into 3 by 2 divided by 3 by 2. So 7 by 2 minus 7 by 2 will be equal to 0. Here it will be 1 into 1 minus 0 into, sorry, yeah, it will be 1 minus 0 into 7 by 2 divided by 3 by 2. So it will be 1 only here. Next it will be 1 by 4 minus 3 by 4 into 7 by 2 divided by 3 by 2. So the answer here will be minus 3 by 2. Here for the next solution value, it will be 180 into, sorry, yeah, for 480, no? Yeah, it will be 480 minus 180 into 7 by 2 divided by 3 by 2. If you do the calculation, the value will be coming out to be 60, right? Similarly, for the values of the x2 row, we have, the first value will be 1 by 2 minus 1 by 2 into 1 by 2 divided by 3 by 2, and the value will be equal to 1 by 3, right? Nextly, it is 1 minus 0 into 1 by 2 divided by 1 by 2. The value will remain same, that is 1. Here it will be 1 by 2 minus 1 by 2 into 3 by 2 divided by 3 by 2, that is 1 by 2 minus 1 by 2. The answer will be equal to 0. Nextly, it will be the next value will be 0 minus 0 into 1 by 2 divided by 3 by 2. So the value will remain 0 only here. The next value is minus 1 by 4 minus 3 by 4 into 1 by 2 divided by 3 by 2, and the answer here will be come out, no, it will be minus 1 by 2. Nextly, we have the value. Next value will be for the solution, it will be 120 minus 180 into 1 by 2 divided by 3 by 2, and the answer here comes out to be 60, right? So the next step we have is to find out the zj values, and after that we'll be finding out cj minus zj, right? So zj values, when we are going to find out, it will be what? It will be 3 by 3 plus 4 by 3. So the answer comes out to be 7 by 3. Yeah. So here it will be 3 only here. It will be 3 here. It will be 4 here. It will be 0 here. It will be minus 3 by 2 plus 4 by 2. And the answer comes out to be 1 by 2. Here it will be 180. That is 3 into 6. That is 180. 180 plus 480. And it will be coming out to be 660. So Cj minus Zj, that is 2 minus 7 by 3, comes out to be minus 1 by 3. 3 minus 3 comes out to be 0. 4 minus 4 comes out to be 0. 0 minus 0 comes out to be 0. And 0 minus 1 by 2 comes out to be minus 1 by 2. So here all Cj minus Zj values, if we inspect, all the Cj minus Zj values are less than or equal to 0. Hence, we have reached optimal solution. Hence, optimal solution reached. Right. So if it is a, no, here we can write here x1 is equal to 0, right? X2 is equal to 60. X3 is equal to, again it is equal to 60. Oh, sorry, x3 is equal to 120, and z max is equal to 660. So this is the final answer for our numerical, right? So I'm